So we have apparently 40 minutes to talk to you about this thing. Who's heard of SBOMs? Okay. Oh, God, I think this, is that hand or half a hand or 2 hands? Okay, cool. Right, so we're going to go through what SBOMs are very quickly. I'm going to try and give you a demo of a tool that might help you understand it a bit better. And then Olimpiu is going to do some more demos of some tools because this is now important stuff for you. Okay, haha. So guess which one is I'm? This is me. So my name is Steve Poole. I work for a company called Sonatype, who do secure supply chain stuff. We're the guys that run Maven Central. So if you're a Java developer, you will be using Maven Central. We also do Nexus and things like that. And so we're in this secure supply chain thing. And for that to be important, it's an important topic now. And obviously embedded in that are new technologies, which is where SBOMs come in. So that's me.
And the other one is me, as Steve already made clear. And I'm the CTO of a company called Mindit. If you don't know about it, so for now, we want to make sure that by the end of the year, we'll do more events in Iași to get the awesome technical community together. And other than that, we are discussing quite a lot about secure supply chains. So let's see what's under the hood.
Okay. Wow. Okay. This slide tries to sum up a bunch of stuff that's happening. So how many of you have seen, oh no, let's pick some old movies, like Ocean's 11. You know, those sort of movies? Okay. Breaking Bad, those sorts of things. You know, what about the drugs? And you think about the drug trade, and you see all these wonderful things that happen. The drug trade makes, for the bad guys, costs us about $450 billion. $450 billion. Okay? And 6-7 years ago, cybercrime was about the same. But roll forward to today, the drug trade is still the same, about $450 billion. But cybercrime, well, hey, look, if cybercrime was a country, it would be the 3rd largest country in the world by GDP. I want you to think $8.44 trillion compared to $450 billion. Significant difference. The point is, whereas the drug trade is manageable because it's a physical thing, and though it costs loads of money, it's nothing compared to where this is going. So cybercrime is just this enormously large challenge, and it is getting worse daily. And as developers, you might go, it's not my problem. But actually, as a developer, it is your problem, because you choose open source. Who downloads stuff from Maven Central? Okay, I mean, who's a Java developer? Come on, let's do the first one. Okay, ooh, not Java developers, ooh, okay. Regardless, if you're a developer, you download open source software, and you download open source software because open source software is free and gives you great stuff. So your business relies on open source software. These guys want to use open source software to get at you because it's a great way of compromising your company, getting in there and doing whatever bad things they want to do. And it's easy, which is why this is just going through the roof. Now, with the drug trade, what happened? The governments got together, organizations, we created solutions, and though it's not necessarily the best, it's manageable. We're just beginning to get them together to fix this problem. And so you will see lots of things coming down from different governments, US, Europe, you name. Everybody's looking at solutions to fix this. And the 2 people they're trying to target to fix it are you, literally you as developers, and the second person is the person in your company who is responsible for shipping the software. So whether you ship software or you provide a service, somebody in your company could become criminally liable if you ship software. Ship means make available software with known vulnerabilities. Think about that. And so you are responsible, and somebody in your company will be responsible. You, luckily, you won't be criminally responsible, but you have a responsibility, and your responsibility is to start to learn all about this and understand how your choices make a difference. Right, I forgot what comes next. What comes next? Oh yeah, more. 742% average annual increase in software supply chain. Software supply chain is this grandiose name for the process of creating and delivering software, which used to be called CI/CD, and nowadays is bigger. But supply chain management is what it's all about, and you are going to be involved in this because the process that you use to deliver software is also a target. So it's not just the open source. So imagine the bad guys. So I mentioned Ocean's 11. If you remember in Ocean's 11, there's the thing, I think it's Ocean's 11, where they go back to Mexico because they want to compromise the dice. Remember that bit? So that's what the bad guys are trying to do. They're trying to get into open source. They're trying to get all the way as far up there as the supply chain as possible to compromise it so that when you consume it, it's got malware in or it's got vulnerabilities and whatever. Okay? That's what's happening here. The number of attacks that we see that are classified in that manner have just gone through the roof. Okay? And we're starting to measure all these things. Another horrible number. This is the number of times you've downloaded, your company has downloaded a dependency at a particular version, whether it's Java or Node or Python or whatever, and in that thing was a vulnerability for which there was another version that didn't have it. And every time that you do this, you make it easier for the bad guys to get into your system because you're downloading vulnerable things. So that's a weakness they could compromise, or worst case, it could be malware. Okay? So these are real big problems. Now, luckily, which the last thing sort of hints at, is we're turning out to say that actually, much as it might sound to you like a chore to have to be told, you've got to update your vulnerability patches all the time, it turns out that, in fact, to get this right is all about automation. And if you can get the automation right and pay attention to this, you can actually be more productive and more secure. And we haven't got time really to talk about why that is, but we have enough data to show that if you focus on security, i.e. panic when things happen, or you focus on productivity, i.e. ignore it all completely and just get stuff out, either of those is not a good idea, but if you can bring them together and you can look at how you develop to deal with this problem, you do it the right way, it's highly productive. And if it's highly productive, that means it's more fun. Right, what comes next? Aha! Yes, so what does this mean? What is it you could do? What is it that happens now that you're involved in that could change? Well, as developers, you pick dependencies. You're the person who pulls down, makes the first choice, whatever it is. At some point, somebody has to go, I need something. And you Google for it, and you find some, you find some version, a left pad or whatever. You go to Maven Central or whatever, you get the coordinates, you put it in. And you download it. And the chances are, at some point, that thing will gain a vulnerability. It will be discovered. And probably you are waiting for somebody else to fix that. You've probably got some security guys who are scanning for things. And so often when we talk about software supply chain problems, or we talk about dependencies or vulnerabilities, this thing comes in, scanning tools, Dependabot, Sneak, Sonatype, you name it, Sonatype. There's loads of people providing scanning tools. The idea is those scanning tools are going to find that vulnerable software, are going to tell you that you have to fix it. Well, given how important this is to get this right and make sure that we can help you remove all those vulnerabilities, it says, how good is your scanning tool? Because the only thing between you and the bad guys is how good your scanning tool is. And I'll lay odds that the chances are none of you have even thought about how any of the scanning tools that you've seen or might be using work. Think about what you have to do. Think about, some wonderful words up here, but think about, I'm trying to find some software. Where does software turn up when you package it? It might end up in a jar file, might end up in a zip file, might end up in a RPM or a YUM, might end up in an image, Docker container. It can end up in all sorts of places. It could be in a jar file, in a zip, in an RPM on a Docker file. It could be anywhere. So how good are your scanning tools at finding the things that you need? And how good are they at finding the things where the bad guys are trying to hide them? Because it isn't just simple things like packages. Hey, I've got leftpad version 1. Can I find leftpad version 1? Can the scanning tool find it? Maybe it can. But the bad guys aren't going to be that simple. Who here has heard of Log4j? Log4Shell. Anybody involved in that nice event? Yes, okay. Log4Shell, worst vulnerability ever, still out there, still being used. It isn't just about have I got a particular version of Log4Shell or Log4j. It's also, is the bad class, the bit that was the problem, is that somewhere in a jar file in your system? Because the bad guys are stealing that class and putting it in different places. And in fact, there are instances where what they've got is a particular method from a particular class has been stolen. So how good is your scanning tool at finding those? Right? And it's not just the dependencies that you choose, right? It's the dependencies of the dependencies, the transitive dependencies, right? Most applications have about 150 of these dependencies. Any of them could contain bad code. So we rely so much on the scanning tools. And so if your scanning tool isn't good, you may have a false sense of security. So that's not good either, because scanning tools work after the fact. They go, what have I got installed? And so what we want to do is flip this. So the SBOM, software bill of materials, the idea is to say you don't need scanning tools. What you need is the ability to have provided to you by the people who provide the dependency an actual list of stuff that they put in it. And if they do something really complicated, you have a complicated list. So you pick something up from a supermarket, it's got a bunch of ingredients. That's what we're trying to get to. Is this the demo? Yeah, okay. Can you bring it up? Because otherwise I'll just kill it. Yeah.
Yeah.
Right. Now, to show you what SBOM is just easy. We'll just show you.
BOM doctor, or you want to
go? No, go to BOM doctor. We'll just go to BOM doctor. Yeah.
Okay.
Yeah. Okay.
Oh, sorry.
That's not BOM doctor. Aha.
That's
live demo. Okay. Thank you. Oh. This is going to be fun.
Yeah, you can check the other one.
Okay. This is going to be fun. Okay. So an SBOM is at one level a visualization of all the dependencies that you've chosen, and a demonstration of how good the Wi-Fi is here. Wow. Okay. Aha. Okay. So Sonatype is in this business. We run Maven Central for everybody. And we're very interested in making sure that you have the right data to make the right choices. So you can Google for this, right? And you can go over Maven Central and you can look at a lot of the downloads. And there will be a link to BOM Doctor for that dependency, and you can get to see these graphs. What this graph tells you is the sorts of transitive dependencies you have. So this is whatever we have here, Swagger Common, okay? That's this thing. And there is this dependencies, and there are dependencies of its dependencies, and so on, okay? That's the first thing that you need, and that's what an SBOM gives you. This vision comes from applying SBOM technology to that dependency, which gives you a data structure, and now you can visualize it, and you can manage it, right? There's no scanning tools involved, because the idea is these things will be built when compilers run and packaging runs, these things will be produced, okay? Automatically. So you don't have to worry about whether your scanning tool is any good because you'll have the data you need to progress. Right? Now, this is great because not only do you get to see these things, it allows us to create tools, which I'm not sure this is going to work. We'll try it. Ta-da! Right. Yeah. Okay. It's a bit small. So now it's a lot easier to connect the vulnerability information to your situation. Now you can be certain that you know what vulnerabilities you've got because all the vulnerabilities in all the databases out there can be applied to this. And this is what SBOM is. What BOM Doctor does is use Sonatype's data and applies it. So you get these scoring things, okay? And it'll tell you, it's not very good, but it'll tell you that you've got a critical vulnerability, or, and this is the next level, this is why this is really exciting, we're looking at the behavior of the open source projects as well. So we're trying to work out whether the open source project, the people who produce the dependency that you're relying on, are good at software engineering. Do they take security correctly? Do they take it seriously? And we're working with the Linux Foundation and others to generate those ideas, those rules. And if you go to Maven Central now, you'll begin to see those things turning up. So we've created this thing on Maven Central called Safety Score. And we're beginning to sum all this up. So the idea here is that you'll be able to use tools like this to see what your dependency tree looks like and make good choices. Because not only can we tell you about a particular dependency and whether it's got a particular vulnerability, we can tell you how good that open source project is in following the guidelines. And I said right at the beginning about, governments applying rules to us. These are the sorts of rules they're going to come down to you. And so we're going, are you doing that? Right? And because we're looking at these things in more detail, we're going to be able to offer you even more because we can offer you better upgrade advice as well. Because one of the problems you have with upgrading is you don't know whether it's going to break things or not. Well, that's all right then. So wouldn't it be good if you could go to a tool like this, decide which things you want to upgrade, and see whether it would work? Does it have breaking changes? Does it bring in worse vulnerabilities? And so this scoring system is designed to help you work out what are the right choices for you that end up with an upgrade that has the least amount of vulnerabilities and is, as far as we can tell, the least likely to break your application. Right. So there we go. That's what we're trying to do. SBOMs are the big thing. Learn all about SBOMs. And we have some demos.
Some other tools.
Some other tools, yes.
So theoretically, this should help you when you're looking for a library. You're just going and surfing on the web. And this is linked to Maven Central, if I remember correctly.
Yeah. So can we just give me, I can't drive your thing. Can you just go to Maven Central?
Yeah, well, you can just
oh, you've got a link, yeah. Hey, like we were prepared or something.
Yeah, just I have to see the screen, right?
Yeah, so if you go to Maven Central, oh dear, I don't know, pick one. This will just be one that doesn't work, but let's go for it. Sorry?
Jackson.
I can't, where is it? Oh, no, I picked the wrong one. Yeah. Okay, go back. I can't drive things remotely. So this one over, let's see what happens. What do we get on here? Yeah, so you can just about see a bomb doctor report there. You can go click on that one. And you can see more information is turning up on Maven Central. We're looking more into what's going on to give you more information. So we just do the bomb doctor link to see whether it works or not. Because it's still slightly experimental. There we go. It's got a thing and 2 dependencies, and something's broken. There we go. I told you it was an experimental tool. Oh. I can't drive it, yeah.
But all in all, the scoring is based on the OSSF, right?
Scoring is based on OpenSSF, some CLO monitor from CNCF, and a whole bunch of stuff that we're doing based on what we can tell about behavior. Because amazingly, lots of developers do the same thing, and so we get, because we own Maven Central, we can see what your patterns are. So we can say, if 10 of you in this room download something at version 1, or no, let's pick a different, you download something at version 5, and then immediately move to version 6, we can tell the next person that maybe they should go straight to version 6 because nobody really stuck on 5. And so that information is getting connected. So if we see something where that version is not particularly optimal because everybody doesn't stay on it, then that affects the scoring as well. And the scoring is going to change, right? Because we're still learning what makes sense. But we have a lot of data. And obviously, we're trying to share this with you so that you can make better choices and produce safer software. So the question is, which we're going to get to tooling, is how do you get SBOMs? What tools are out there?
We'll just jump into that right now. We'll jump into that right now.
I'll hand over, let you do the other demos.
Yep. But other than that, what would be the rule of thumb when picking a library? What would be the decent score that you would aim for in order to be safe?
I think they reckon about 350. Anything lower than that is a bit suspect. But having said that, bear in mind what we're recording here is reality. It's what's the baseline? Well, how are people operating? That is going to change because as it becomes more important to do this, the open source projects that you're consuming, they are changing. So we know with some like CNCF stuff, the Cube guys, they're already going, okay, there are things we have to change to improve stuff. Okay. Anyway, let's do the tools and then see what we've got left.
So going back to your question, it's this thing. So rather than being static analysis, as you mentioned, and going into the code, it doesn't look into that. The SBOM is just the list of everything that is under the hood, and that usually comes, if you don't have it, coming with from the producer that comes and says, okay, these are the things that you bought. Actually, these are the ingredients. You just go and take all the things that you usually have in your repositories. Either there are code repositories or it's containers or whatever you want, pods. You just transform those into SBOM, so software bill of materials. You can generate them, and that's one of the tools that we'll present in the upcoming moments. There are 3 standards in terms of SBOMs, and they are approved by the almighty first coder of America, Joe Biden, that signed a decree a couple of years now already. But the ones that are the most popular are the one from the Linux Foundation, that's SPDX, and the other one is CycloneDX that is coming from OWASP. Even though OWASP is a little bit more challenged these days in terms of the vulnerabilities they have. And what's happening, actually, you just have a big pair of glasses that goes over all these things and just goes into the reference library. And there are a bunch of them where you just see whether there are any known vulnerabilities attached to them. So just consider it a SBOM vulnerability scanner is just like a librarian that knows all the library that she has behind her, and she just goes letter by letter and she says, okay, this has attached that vulnerability, it has that given score, and based on that, you'll have more impact to everything that you're doing. So this is the basic flow. This is the X-ray that we promised in the beginning, where you just take the repositories you have, you transform them into labels. If you don't have the labels, you generate them yourself, and then look into that. And hopefully, this part will skip. We don't have any vulnerabilities, no COVIDs for your code, and you have to jump the patching work. But actually, the magic is happening here. Here is the library, and you're as good as the data that you use. And one of them is the Sonatype index, where they aggregate all the information from multiple sources. The other ones that are worth being mentioned are, we'll not do this, we don't like dogs, so it's the one from Snyk. Then if you look, usually when there is a vulnerability, Log4j had it as well. On GitHub, you'll find a security advisory where you just provide all the information, how you can replicate that vulnerability, how is the attack vector. So, this is the question that you wanted to answer yesterday. You have, on GitHub, you have information on how you can attack and reproduce that particular issue. And then there are the other ones, the OSV, that's the one from Google. It's open source, and you get the information there. And the other ones have some as well. I don't know if you heard about this company. It's a small company called Oracle that has something they do as well in that regard. SUSE has one, Debian, and Debian is very careful with what's happening in Red Hat. So pretty much these are all used by the tools that I'll present further. So this would be the normal flow where you just identify the things. And some of the tooling provide something that is called an EPS score, and that's the probability that one of the vulnerabilities you have is it will be exploited. So to just provide, usually you see a lot of them. So how do you put priority? What's the absolute priority into patching those? What's the most probable that will provide you the leverage into obtaining the results that you have a safe software? So that's where EPS score comes into place. And usually what's coming out on this side, it's another standard. It's called VEX, called by CycloneDX, the guys that are giving also the standards that are providing the information into what are the vulnerabilities and reports for that. Here are a bunch of other tools. Another startup company, Microsoft, that has another SBOM tool that it's open source. And then obviously each of the vendors are creating their own. So there are tools for Kubernetes, there are tools for Docker that are just creating SBOMs that based on that then you can use on different other tooling. And SBOM Doctor provides the ability of uploading your own SBOM, and that's a quick win in case you want to check something without putting it into your pipeline. But obviously, and then the CycloneDX and SPDX have Maven plugins, Gradle plugins as well, so to make it easier to incorporate in your projects. And because we know that in order for something to work, we need to have it in the terminal, and that's what we like, or at least the ones that have a little bit more gray hair like it to work in the terminal and to pipe it, and then to have it all the way in your Azure workflows. And we'll look into 3 tools or 2 of them. The pink one and the blue one usually go together. So yeah, as you know, that all the girls can tell us that pink and blue go together, right, in terms of color. SIFT is generating the SBOMs. It supports currently 3 formats, and that's CycloneDX, the one from OWASP, SPDX, the one from the Linux Foundation, and its own format, because we like to have our own formats in software industry, right? It's better to have some kind of gap. And the one in the middle is Bomber, and the reason why I put it here is because I am part of the organization that is building it. It's open source, even though up to now I didn't do anything but review, but hopefully I'll do that through the year. And the other nice thing that it has is the fact that it provides an EPS score. So theoretically, it should help you prioritize the way how you should tackle the vulnerabilities, not just based on the score, if it's critical or not. And now, if the almighty gods of the internet will help us, we'll see also how they act in practice, if I can manage to drag this thing on the screen somehow.
Can you just mirror your screen?
Yeah, thank you. I can mirror my screen. I cannot. Okay, then I'll drag it. Or I'll not drag it. I bet that nobody had.
You've lost the mouse, I know.
Yeah, I lost the mouse. And I lost the keyboard. Oh, no. Okay, and let me drag the terminal here. I bet that nobody has these problems during their demos, right? Okay, so something that goes with the chairs in the room, something green. Okay.
Make it bigger?
Yeah, I'll just do that right now. So, as mentioned, there we'll look into 3 particular tools. One of them is Sift, and Sift and Gripe are both coming from Anchor, open source, built in Golang, for those of you that are interested about what's happening under the hood. And let's clear the screen. So, as mentioned, you can scan, or you need to scan containers, you need to scan jars, you need to scan pretty much everything. Scan yourself, as you're talking about an X-ray. And what we can do is to just generate a BOM. Just looking at it, usually the default version, it has, I'm playing tricks now because it's hard. This is one of the Docker images that I have on my PC, so I'll use this one. It's a Spring Cloud template. And if you just go by the default one, you'll just have the first level, the superficial level, where you use just the direct dependencies, as Steve mentioned earlier. And I use this format, the CycloneDX JSON, because we do like JSON, right? And what it will do, it will just load the image. And after that, it will just go into parsing, cataloging, and here it is. And, well, we can just go and try to do it by hand and just look at everything and try to figure out what the vulnerability is. But obviously that doesn't work. And if we just do the more important stuff, is that we need to have the whole scope. And that will yield a lot more problems. That will just go through all the layers, and it will go recursively to the dependencies of the dependencies, and somewhere it will stop, but I don't know exactly how far it goes in terms of that. And that will generate, again, the SBOM. And it's, as you can see on the other side, it provides the information about the packages. Let's take one of them. For instance, this one is the jar itself. And it just points out the metadata where you can find the information, the type of operating system, and pretty much all the type of things.
So while that's not there, the objective is that you'll have something like this that tells you what you've got, and it will eventually link off to its own SBOM. At the moment, you get that we're generating them, but we're generating at the end. But these things are going to get generated during the process. So where the where CycloneDX says XYZ, it'll be XYZ, and here is a link to a provable SBOM for that thing. And you better follow it and look at it, and it'll have its dependencies and so on. So you imagine a tree of URLs.
Sorry, I stole the start because Bomber is, even if, you know, it's like the bombers of the Second World War that is going very slow.
Yes.
And the reason for that is that because it relies on OSV, and the OSV one, currently the parallel batching, if you reconnect to the keynote today, the parallel batching is not working as expected. So actually it's doing this iteratively, and there is a lot of things to happen. I'll actually stop it, and then I'll show you the
because I want to be clear that right now these tools are doing the scanning that I said we're going to try and stop doing. but we have to start somewhere. But the aim is that these SBOMs aren't generated by standalone tools, but the process becomes part of the packaging and the compiling, so that you get an SBOM. When you do Java C, an SBOM will turn up. That's the sort of aim. And when you create an RPM, an SBOM will turn up. But at the moment, we haven't got that connected, so we have these tools that are generating the SBOMs, because you've got to start somewhere. Yeah.
And the reason is more than it's normal and it's needed to be done.
Yeah.
It's important. It will be mandatory in a lot of the situation. U.S. signed an executive order a couple of years back, and it will just be, I think next year, it will just get into execution. And in Europe, in January, the NIS2 directive for the security side was signed, so more often than not, it will just be important. Important to have it, because otherwise you'll not be able to operate the software that you have in certain countries. And last but not least, it's, I don't know what I wanted to say, because I'm just looking at that one that is not working, so I'll just stop it and we'll go
it's not working.
Yeah, I'll go to gripe. Okay.
You get going. So while you're doing that, again, the bomber is I have an SBOM, and there are all these vulnerability databases out there, and can I match them? And again, that's always going to be needed, because somebody still has to have the data that holds all the discoveries about vulnerabilities. And so, again, you can see the bits coming together. We're getting tools generating SBOMs because, as Olimpiu said, we've got, like, the US government are saying, you can't trade with the US government from a software point of view unless you have an SBOM, right? Because they're trying to force all this. So this is what's coming, right? It's not here yet. There are lots of ways to go, but this is where we're going, and this is going to become part of your life. SBOMs are going to be in supply chain to terminals that are going to be there all the time. And this is the first step, but it will continue as they tighten the screws to say there are more things you need to do, because this is a technology piece. The other piece that's coming will be how you do software development, how your build processes work, how your CI/CD systems work, how you secure it, what audit trails you have. All sorts of stuff are coming down about how we work, but we're starting here because this begins to fix that big problem we have about whether the scanning tools your scanning tools are any good.
Oops. Yeah. Okay. I'm old. I have to take my glasses.
What was the last one we were going to do?
That's it.
I thought you had one more. Oh, gripe. Yeah.
Yeah, gripe, but I cannot see the typing. Bit money, right?
You can go look behind you.
Yeah, I have it there. Yeah, well.
Okay. Well, look, we got 2 minutes 41 seconds. Are there any questions so far, excluding you? Any other questions? Yes.
There are tools like Triving, if you've heard of it. It's a tool used by scanning tools that actually do something like this. But I don't know if they also out of this one. But they do operate in the same method. They scan the image and then they go deeper.
Yeah.
They also scan dependencies.
Yeah. Okay.
Something that you would add in the pipeline, for example, when you build software, because it takes a lot of time. My experience was with this tool, it takes a lot of time.
It does take a lot of time, if they're not producing SBOM, they will, because it's important. The joining of the SBOMs together is the bit we haven't got to yet. But when that happens, it becomes easier, because you just have to find the top-level assets and then look for the SBOMs. But at the moment, all these things go as deep as they can. But this is where we're going. Yeah. Okay, go on then. Go on. What's your question?
That was just a thought. So when you publish your SBOM, you're basically telling exactly and explicitly and publicly what you have and what vulnerabilities can be open for. So what are the thoughts on, like, I'm not saying it's a bad idea. I think it's a good idea. But any thoughts on basically telling where the keys to your house are and how they look like?
So there are some people, some companies, who would like to redact SBOMs. and provided a short version. But of course, the point is, it's about you proving that you have safe software. So the analogy is, okay, so the analogy that gets used is that if you're a car manufacturer and you sold a car and you knew the airbags weren't working, you would be culpable. So this is the same thing. You have to prove that your software is not vulnerable. So if you ship an SBOM and with a bunch of information in it, and those things have high-level vulnerabilities, well, you've just shot yourself in the foot anyway. So the answer is, people have had that conversation, but the net is that currently you have to be open about these things because it's the only way that you can be somebody can trust you.
And it's pretty much the same if you look at open source, right? Open source is growing and growing and growing, and it reached 90%, and it's pretty much the same thing. It's open source, and you don't think that it will be worse, but actually you have more people that can work on that.
I agree. The reason I actually mentioned that because a lot of people think that and ask that, and I kind of want to actually kill that thing.
Yeah. Okay.
Yeah.
All right. So was there another question? Yes. No, what the SBOM will tell you is that you didn't get a complete version of that thing.
Yeah.
Because your SBOM, the objective of the end is the SBOM connects things together with provable digital signatures. So if you have a build process that takes something down and chucks half of it away, then you've created something new. And so you have to have an SBOM for that thing. Yeah. The bad guys would have to figure out, have to guess what the bits that you've chucked away, the bits you've kept, right? So your SBOM wouldn't say, I've got this Spring thing, because that's not true anymore because you've taken stuff out of it. But you would have to declare those classes as a separate thing, right? Yeah. Yeah, I mean, believe me, there are these interesting edges around this stuff about what happens if bad people do these things. But the whole point here is you're not relying on these scanning tools that may or may not be good. We are telling people exactly what we've got in our system so that somebody else can work out that they've got the vulnerability. Because the other analogy here is, currently, when you use somebody's piece of software, it's like you get given a cake. And you have to work out how it was made, what eggs are in it, what flour is in it, and where those things came from. Right? And that depends on just how good your forensic analysis tools are to work out that cake had these eggs from this supermarket. The SBOM inverts that and says, here's the cake, and here's all the ingredients, and where we got them from. And that means we have a much better ability to spot that your cake has got bad eggs in it. Okay, right. And on that, I think we're done. Thank you.
Thank you.